Hi, my name is Michael Stavridis. I am a Principal Solutions Architect with P0 Security. P0 Security provides a next-gen PAM solution for all of your public cloud and on-premise infrastructure identity security needs. In a moment, I will go over a high-level demo of our product, and I'll also do a deep dive in our posture, orchestration, and governance features. All right, let's jump into an overview of the P0 platform. Here we're going to see our dashboard. On our dashboard, we are going to represent with each of these widgets our posture, our governance, and our orchestration tools within the platform. Here you can see our posture, which is going to show all of the identity-related risks within your infrastructure. Next to that, we have inventory, which represents the governance part of our platform. You'll be able to see all of the identities, the entitlements, and credentials within this widget. But on top of that, we also discover and inventory all of your resources within your cloud and on your on-premise environments. And below that, we have our widget for our just-in-time feature. This shows the most frequent requests from your users, and it also shows you a summary of the approval times, the access durations, and much more. We'll jump in and quickly take a look at our posture. So out of the box, in our posture view, you'll be able to see dozens of risk findings within your public cloud. These work as soon as you hook up your infrastructure to our platform. In our inventory view, which you can see here, you'll be able to explore your identities and how they're related via the entitlements, credentials, and the resources that they can access. From here, we have our just-in-time tool. This allows you to grant yourself ephemeral access to any of the resources in your public cloud or your on-premise. We also offer the ability to SSH, access to RDS, Postgres, and other integrations such as Snowflake. To grant yourself ephemeral access, simply push the request access button, in which you'll be presented with a dialog box to be able to access and make an approval request within your on-premise or cloud environments. Let's do a deep dive into the P0 platform, specifically our posture feature. Here you'll be able to find many of the risk findings that are commonly found within cloud and on-premise environments. We have already built out several risk findings that will get you 95% of where you need to be when it comes from a security hardening standpoint. Here you'll be able to see things like GCP role bindings that have unused privilege access, unused user accounts, stale service account keys, and many more. For the time being, what we'll do is we'll jump into a critical risk finding that is the GCP role bindings with unused privilege access. In this view, you'll be able to see all of the principles related to the entitlements that have unused privilege access. This is so you can quickly assess and be able to get your cloud environments and your on-premise environments to least privilege. What we'll do is we'll take a look at a non-human identity. In your cloud environment specifically, and also with hybrid environments where you have both your infrastructure located in, say, a data center or also within a public cloud environment, a lot of times non-human identities go overlooked. A lot of companies already have user access reviews, but they do not have user access reviews for the non-human identities. What we're going to be looking at is directly at a Terraform deployer account, which is a non-human identity that is used to deploy Terraform within GCP. Within the P0 platform, we can quickly search for it. And as you can see, we have two principles that have two entitlements attached to it within our dashboard here. What we're going to be looking at is the one specifically that has the entitlement owner. Here in the mini node screen, we're able to see the unused permissions within that entitlement. On top of that, we have also shown the privilege permissions along with the risks that are associated with them. What we've also done is created a catalog for both the permissions and the risks to better understand what exactly they mean and what the possible security implications that they may have. Here in our catalog, we show what the permission means and the associated risks with them. We've also done this for the risk itself. Here we show what the critical risk means when it comes to data encryption, along with the permissions that could be affected by this risk. We've also noted sometimes that attack paths can get a little overcomplicated and crowded. So what we've done is broken down that data in an easy and more digestible fashion where you can view the risk and the associated permissions with that. Not only do we give you the ability to identify risks like this, We also give you the ability to remediate them. In the top right corner or top middle corner, what you'll see is a Review Fix button. From here, you'll be presented with the Google Cloud Shell. What this Google Cloud Shell will do for you is it'll remove the entitlement owner. It will create a new entitlement that is least privileged and attach it back to the principal or the identity that it is associated with. We also give you the ability to risk accept or ignore risk findings if you find that this is something that is acceptable within your environment. To do this, you can click the ignore button and it will no longer show up as a risk finding within your environment. Along with that, if you have some type of ITSM tool, say like Snow or Jira, we're able to send this information that is associated with this risk finding directly to it. Simply click on the assign button and it will be pushed, in this case, to Jira. Let's jump into our inventory page. From our inventory page, we'll be able to explore all of the identities and the relationships they have with the resources within your infrastructure and environments. This page is very useful for trying to figure out who has access to what and what they've done with that access. Here we'll go over something that a lot of organizations fail to do. While a lot of organizations have regular user access certifications and user access reviews, what they do forget is to do the same for their non-human identities. Once a service account or a non-human identity is created for an application, it is usually forgotten about. We give you the tools to be able to explore those relationships, and we'll also be able to look at things like lateral movement and toxic permission combinations. The first thing we'll do is we'll look at a non-human identity, the Terraform deployer account, in which we will explore what credentials may have been created for this account, along with the lateral movement those credentials could lead to. To do this, you can simply click on the Show Credentials button. And in our case, we have a query already saved and created, so we can bring up all of our saved queries. In this case, we'll be using the Terraform deployer account. And this will bring up all of the credentials that are related to the non-human identity Terraform. We can also see this from a graph view. In this graph view, you'll be able to see the credentials themselves on the left side and the lateral movement that this specific Terraform deployer account has through its entitlements. As you can see, this Terraform deployer account has lateral movement from these credentials into other accounts. We can also see this from an identity standpoint. What we're doing right now is looking at it from a credential standpoint with the 5 keys. So to simply do that, we can do the same thing, but we're going to look at it from identities, and we're going to bring up a new search. Here in this view, what we're seeing now is identities along with the entitlements that give lateral movement into this specific Terraform deployer account. And then on top of that, we can also see the further lateral movement they can have throughout your GCP organization. As you can see here, all of these service accounts and identities have the ability to move it and impersonate this Terraform deployer account, and then laterally move through your organization through more service identities that are given access through the owner entitlement. For the sake of this demo, we're going to actually pick on this user, Alice Johnson. Alice Johnson is an identity that should not have any standing access or any access to give her lateral movement into this Terraform deployer account. Just like we're seeing here, what we can do is we can see specifically for this one identity what access she has and what lateral movement she might have from her account. What we'll do is bring up another search that specifically queries the user Alice Johnson, looking at the entitlements and lateral movement that this account may have. What you can see here is not only the entitlements, but the groups that are attached to this particular user, along with the entitlements attached to the group that this user is in. These groups and entitlements give her lateral movement into accounts that she should never have access to, which could possibly be a massive issue if her account ever is breached by a threat actor. As we know, when an account is breached, it's usually a human identity that does this. And when this account is breached, they generally laterally move into another account, say a Terraform deployer account, to gain further access within your environment. Using these tools, you'll be able to quickly identify these toxic combinations and help eliminate these problems from happening in the future. Let's jump into our just-in-time feature. At P0, we believe that human identities should not have standing access, and instead, what they should have is ephemeral requested access through just-in-time. This allows you to reduce the attack surface and the blast radius when an account may be compromised, and it also allows you to track for auditing and compliance purposes what every user has and what they have done with their access. Here you can see in our just-in-time screen the active and pending requests that you might have within your environment. In the top right, you can actually request access directly through our web portal. You can also request access through our Slack or Teams integration. Let's jump into requesting access through our web portal. When you click Request Access, you'll be presented with a dialog box that's asking you to select a resource. These resources will be shown by what you have within the P0 environment and within the integrations page. As you can see here, we have AWS, Azure, Google, a Postgres database, and the ability to request access into a EC2, VM, or a compute node. What we'll do here is we'll ask for the editor role within a GCP project. After selecting Google Cloud as a resource, you'll be able to select either a resource, a role, or a permission. The most common type of request that we see is generally a role for an entire project. Once we select role, we'll be presented with choosing what project and what role we would want within that project. In this case, we currently only have one project, which is the Got Demo project. For role, what you can do is as soon as you start typing, it will start searching for those roles within that GCP project. In this case, we'll be looking at editor. I would like to note within one request, you can actually ask for up to 10 different roles. In this case, we're only needing editor. Next, you're going to need to put down a reason of why you're going to need this access. This reason is actually shown to the approver and lets them know why you're requesting this access. And last, since this is ephemeral access, it's going to ask you how long you need this access for. For this demo, we're just going to do 5 minutes. All of the times that you saw within the access duration dialog box are able to be set within our P0 management settings page. Now, when I click request, it is going to send out a request to an approver to review and either approve or deny. And as you can see now, Michael Stavridis now is requesting the role editor into the Got Demo project. Here I can approve or deny this request. In this case, we will just click approve. When I click approve, it's going to present me with a dialog box asking how long I should give access to this user. The user requested 5 minutes, but if I wanted to, I could change this to 30 minutes, an hour, or a week. Once the request has been approved, it will go out to GCP and provision the access for that particular user. As you can see now, I have an active ephemeral request access for the role editor. If for some reason you need to revoke the access for the user, it's as simple as just clicking revoke. What this will do now is it will go back out and deprovision access for that user, and they will no longer have the access within GCP. P0 also allows you to request access through chat programs such as Slack, Teams, and we also offer custom integrations along with the ability to have notifications and requests done through email. In this case, we will go over how it works with Slack. To get started, you'd simply just need to install the P0 security integration with Slack, and then from there, you'd be able to make a request directly to P0. To do so, you would just type /P0 request. You'll be presented with a dialog box to pick the resource that you would like access to. In this case, we're going to do AWS. Specifically, what we're going to be looking for is a permission set within AWS. I would like to note that you can also ask for user policies or direct access to a resource within AWS. Once you've selected permission set, you'll be presented with a dialog box asking for the name of that particular permission set. In this case, we have named our permission sets the same as the departments that the users are in. For the time being, we were just going to select engineering, and we're going to put a reason in just as demo. Along with that, we'll set it for 5 minutes. Just like through the web console, you'll be able to click request, and this will simply go out to the approvers that you have set up within your routing rules, and it will ask them to approve or deny that request. Not only will you be presented within your channel an approve or deny, the requester is also going to be given the information on the original command. So if they have to make this request in the future, they can simply copy and paste this, and it will instantly make this requested access to the approver. Not only can you ask for ephemeral access on the spot, you can also ask for pre-approved access. What this does is it allows you to ask for, in a certain time frame, let's say a week, the ability to be pre-approved for any request you make going forward. To do this, it's much in the same way as doing a P0 request. Instead, what you'll do is do a P0 allow. Much in the same way that you see for P0 request, you'll be asked for what resource you're looking for. And again, what we'll do is we'll look at AWS. It'll also ask you the same thing for access type. The only difference with the P0 allow command is it's going to ask you for the principal. So you can do this for yourself or you can do this for another user. So they don't have to wait for approval from a user for any of the requests they make going forward. Within the P0 allow dialog box, it's going to ask for a starting date and an ending date. Once this has been done, you'll be given pre-approved access for whatever permission set, role, or entitlement that you've asked for on that principal. Here we have the history of all of the just-in-time requests. We catalog all of the requests, approvals, and we also do session recording on what the user did while they had those permissions. As you can see here, under Michael Stavridis for Google Cloud, we can see exactly what they requested, the time frame of what they requested and approved, and how it was done. But we do take this a step further. As we mentioned, we do session recording on what the user has while they requested this ephemeral access. As you can see here in another request for administrator access within AWS, we'll be able to quickly look and see what this user had done when they had these permissions. Not only what they did within the browser or what they did while they used CLI access. As you can see here, this user particularly was looking through an S3 bucket through their browser. This makes it very easy when it comes to SOC 2 compliance, as you know exactly what happened within your environment while they had these privileges and permissions. Here we are at the just-in-time routing page. This is where you can define how your P0 requests are routed from your requesters to your approvers. This gives you fine-grained control of how those things are handled within your environment. We also give you the ability to look at the YAML view if you wanted to have even more fine-grained access on how these routes are configured. Our just-in-time feature not only allows you to request entitlements within your on-premise and cloud environment, but directly to resources such as virtual machines or Kubernetes clusters. Here I'll show you how to SSH into a virtual machine within AWS. To do so, we need to list out the resources that we currently have access to. As you can see, we have access to resources within AWS and Azure. What we're going to focus on is the AWS resource, the SSH demo node. What I can do from there is I can make a request into this particular node, and once it's approved, I'll be jumped right into this particular node. As you can see, I've made a request, and here in Slack, you can now see that I have an approval request that needs to be approved or denied. From here, I can select how long this user needs access for. For the sake of the demo, we'll use 5 minutes. Once I've clicked approve, what will happen is it will begin provisioning my access directly within this virtual machine itself. Once that's done, I'll be brought to a screen that's asking me to provision my access. Now that has been done, I'll be jumped directly into the box, and as you can see now, I am on a virtual machine that is running Amazon Linux 2023. With the P0 CLI and just-in-time feature, we're also able to access resources such as Kubernetes clusters. So what we can do with the CLI is we can look at what resources we have available, in this case, the Kubernetes clusters, what roles we have associated with that, which pods belong to that Kubernetes cluster, and also be able to configure our CLI terminal to execute as shell within that particular Kubernetes cluster. To see what clusters are available to us, we can execute the ls command for Kubernetes. As you can see, we currently have one Kubernetes cluster available to us, the EKS demo cluster. We can also check what pods are available within that cluster. In particular, we're going to be looking at the Nginx pod. Along with that, we're able to list out the current roles that are available to us through that Kubernetes cluster. So from there, we can actually configure our terminal through the P0 CLI to allow us to have access to that particular Nginx pod. Once we made the request to allow access to the Kubernetes cluster, you're going to see within Slack a request approval. Once this is approved, it will go out to the Kubernetes cluster, provision the access required, and allow us to access that particular pod. And that's it. If you're looking for more information on P0, or you would like to start a free trial with us, please feel free to visit p0.dev or email us at support@p0.dev. Have a great day.